Okay, so now I want to talk about something that I think is unique behavior to Python, and if you're coming from another language, sometimes this can be a bit confusing and cause you some grief. So in Python, there are some types of variables that can't be changed, and then there are other types of variables that can be changed. And variables that can be changed are known as mutable. So an example of a mutable type variable is a list, and we'll talk about lists later, but basically it's just a series of values, right? So I'm creating this list, which is specified using square brackets, and this list contains three numbers, 5, 6, and 7. So here I'm basically saving that list to the variable a. Then I'm creating a new variable by setting it equal to a, and then I'm appending a new value to a, and then plot it or printing back a and b. For now, I'm going to just comment out these bottom lines because we don't want to look at those yet. Okay, so if I print back a and b, what do you see is they're actually the same. And initially, for me anyway, this wouldn't really make sense. So first off, we create a with three variables in it. Then we create a copy of a and save it to the variable b, and then we append a new value to a. But as you can see, that new value got appended both to a and to b. And the reason why that happened is because in Python, since list objects are mutable, you're not actually making a copy of a when you set it equal to, or making a copy of a when you create the variable b. Instead, you're just referencing the same data in memory. So a and b actually point to the same information or the same data stored in your memory or stored in your RAM, and thus a change made to one will affect the other. So this also works the other way around. So for example, if instead of doing appending something to a, we append something to b, it's going to have the same result, and that both a and b will be impacted. If you want to see if two variables point to the same data or the same object in memory, that can be accomplished using the ID function, and also you can use this is test. Basically, this tests whether a and b are the same thing, and then ID returns like the memory ID for a and b. So if I run this code, we can see here that again they are the same object, and the location in memory is the same. So these two objects these two variables point to the same object. So in Python, if you wanted to actually make a copy of a variable, copy the data associated with a variable into a new location in memory, and then work with that, how do you do that? Well, you have to do that by creating a copy. So you can create a copy by making use of the copy module, which ships with like base Python. So here I'm importing that module. We'll talk about module imports at a later time. Basically here, but importing this module allows me to make use of some additional functionality that's provided by this module, which is basically a Python-like extension. Okay, so now when I run this, instead of doing b is equal to a, I do copy.deepCopyA. So basically, deep copy is a function that comes from the copy module, and what we're doing then is copying a into b. So what this actually does then is it makes an actual copy of the data instead of referencing the same data in memory or the same location in memory. So then if we make a change to a or b, it's not going to affect the other. So we can test that again with is and ID. So again, here I created a series of three values. I appended a new value to a, but that new value didn't get appended to b because a copy was made of a before the value was added to it using the append method here. And again, now we return false as opposed to true because they're not the same object, and you can see they have different IDs, right? So that's an important thing to note in Python. Important thing to note in Python is that if you have a mutable object like a list, then if you just simply set another variable equal to that variable, it's still going to reference the same data in memory. So changing one will affect the other. If you actually want to make a copy or create a copy to a new location in memory, you can make use of the deep copy or copy functions that are made available through the copy module.